In this video, section 4.1, square roots. Now, we're going to talk about square roots. We might as well start by talking about squaring. So let's take a number, say 7, and square it. Well, that's 7 times itself. And the result is 49. Now, let's also take -7 and square it. And notice how I have parentheses and then the square, and that's outside the parentheses. It's very important. Otherwise, the negative sign wouldn't be being operated on by the squared. So -7 squared is equal to -7 times -7. The result of that is positive. There's two negative signs, they make it positive. So we have positive 7 times 7. 49. So when I say, what's the square root of 49? What I'm asking you is, give me a number that when I square it, I get 49. There's two such numbers, both the positive and negative square roots, plus or minus 7. And we use this stacked plus or minus sign to indicate that. Each of those is a root, and they're a separate number. Let's take a look at using this. Let's solve an equation. 5 times the quantity x squared minus 3 is equal to 77. Okay. This is an exponent. So in terms of order of operations, let's see, here goes parentheses, exponents, multiplication, addition. So when we're using inverse reverse, we're going to go backwards, and we're going to do that last. So we'll start by adding 3 to each side. 5x squared is equal to 80. Then we'll divide both sides by 5. X squared is equal to 16. Now, what we want to do here is take the square root of both sides. It's an operation. It's the inverse of this exponent to the second power. So we're going to have to apply it to both sides. So this is the square root of x squared is equal to the square root of 16. The square root and the exponent, like I said, they're inverses. They cancel out. Our left-hand side is just x. And what is it equal to? It's equal to plus or minus 4, because 4 times 4 is 16. Let's take a look at another example. We're going to have 3 times the quantity x minus 2 squared plus 5 is equal to 13. Now, in terms of order of operations, we're going to take care of the exponent, then everything inside. So this stuff right in here, this is going to be taken care of last. I'll write that a little bit darker. That's going to be last. This will be second to last. These guys are going to we're going to get rid of right away. So to start, we're going to subtract 5 from both sides. 13 minus 5 is 8. And that cancels out the 5. So we have 3 times the quantity x minus 2 squared is equal to 8. Now remember, parentheses, exponents, multiplication, addition. We need to undo the 3 before we undo the 2. Multiplication before exponents when solving. Okay, so we divide both sides by 3. And we have, well, we can't simplify this. It's just 8 divided by 3. And that's equal to the quantity x minus 2 squared. Now, we're going to want to take the square root. Square root, this radical and the exponent cancel out, and we're left with x minus 2 on our left hand side, and that's equal to plus or minus the square root of 8 divided by 3. The name for a number like the square root of 8/3 is irrational. We can't even simplify this down to a fraction. The only way we have of expressing it is the square root of 8 divided by 3. So we're just going to leave it like that. We still have to get rid of this 2, so we're going to add 2 to both sides. X is equal to 2 plus or minus the square root of 8 divided by 3. And that's our solution. We can't simplify it or anything. Can't do anything with it. That's the solution. Let's take a look at a little bit of a different problem here. Let's take x squared, add 8 to it, and set it equal to, oh, I don't know, 4. Well, the first thing we're going to want to do is subtract 8 from each side. So it'll be x squared is equal to, negative 4. Let's think about this. If I take 2 and I multiply it by 2, I get 4. If I take a negative 2 and I multiply it by a negative 2, I get 4. To get to negative 4, we'd have to take 2 and multiply it by negative 2, or negative 2 times 2. This negative 2 is not 2. So these aren't squares. I can't find a number that when I multiply it by itself, I get negative 4. So what does this mean? Square root of negative 4 does not exist. There's no such number. So what should we do if we encounter something like this? We can just go ahead and say, look, x is equal to plus or minus the square root of negative 4. If this number did exist, it would be the solution of our equation, but it does not exist. So we're just going to pretend like everything's fine really when we're solving, but we're going to know that, hey, this isn't a number. And by writing it like this, we show whoever's looking at our work, look, this problem doesn't have a solution. Let's take a look at a problem that does have a solution. Let's take x, add to it 4, square this, subtract 10, we'll divide this entire thing by 2, and then set it equal to 13. Well, multiplication, addition, exponent, then whatever's in the parentheses. So we'll get rid of this division by 2 by multiplying by 2. 2 times 13, we get 26, and that's equal to the right hand side minus that fraction, or excuse me, the left hand side without the fraction. So we'll add 10 to both sides. Okay, now we have the quantity x plus 4 squared is equal to 36. It's time for the square root. So we'll take the square root of this. set it equal to the square root of 36. These cancel out, the square root and the square, so we're left with x plus 4, and it's equal to 6 plus or minus 6. But we still need to solve. We don't have just x is equal to. This is not a solution. We need to subtract 4 from both sides. Plus or minus 6, that represents a positive 6 and a negative 6. So I can simplify this out. 6 minus 4 is 2. Negative 6 minus 4 is a negative 10. So we have two integers as our solutions. Positive 2, negative 10. When we hit this spot, we said, look, let's break it up into two cases. Case 1, it's positive. Case 2, it's negative. Suppose it's positive, we subtract, we get 2. Suppose it's negative, we subtract, we get negative 10. That's it for section 4.1. Thanks.